Hi, this question number 7 is taken from October 2002 Advanced Level Maths HSC S2. Bottles of wine are stacked in racks of 12. The weights of these bottles are normally distributed with mean 1.3 kilogram and standard deviation 0.06 kilograms. The weights of the empty racks are normally distributed with mean 2 kilograms and standard deviation 0.3 kilograms. First part, find the probability that the total weight of a full rack of 12 bottles of wine is between 17 and 18 kilograms. And for the second part, 2 bottles of wine are chosen at random. Find the probability that they differ in weight by more than 0.05 kilograms. Okay, so for the first part of this question, let us define a random variable here. So x will be the random variable for the mean weight of for the bottles of wine, and I'm going to define a second random variable. Y is going to be the mean weight for the racks. We should remember that the mean weight here for the bottles is given in the question as 1.3 kilograms, and the standard deviation is given as 0.06 kilograms. And also the mean weight for for the racks is normally distributed as being 2 kilograms, and the standard deviation here is 0.3 kilograms. Okay, so we need to find the probability that a full rack of 12 bottles. Now for 12 bottles, what is it going to be? For 12 bottles, let's just say 12 mean of x. Alright, 12 mean of x is going to be then 12 times 1.3. Okay, and that's going to give us 15.6, and also the standard deviation is going to be alright. So okay, so let's put the variance. Okay, the variance of x for 12 bottles, 12x, is going to be then 12 times 0.06 to the square. Okay, for the variance, and if you do that with the calculator, you're going to end up with 0.0432. Now the variance, what about the mean of y? So one rack, 1 times the mean of y for the racks is going to be 1 times 2, and that's going to give us 2, and then the variance of y is going to be then, the standard deviation is 0.3, so that's 1 rack times 0.3 squared, and here we got 0.09. Add all of that up, you're going to end up with what am I doing here? Yeah, that's the variance. That's fine. So the mean, total mean, okay, of one rack with 12 bottles is going to be 17.6, and the variance for 12 bottles in one rack is going to be the sum of that is going to be 0.1332. Right, so we're ready to go now. We're supposed to be calculating the probability that the total weight of a full rack of 12 bottles of wine is between 17 and 18. Okay, so that's quite easy now. We're going to have to standardize in a moment. So we're going to say probability of 18, x being less than yx. Maybe I'm going to put w here, which is much better because w is the weight, isn't it? So yeah, weight, and we have so w being less than 18, alright, minus w being greater than 17. This is going to be greater, yeah. So for this one here, we're going to take it as 1 minus the probability that W is less than 17. Okay, and what is the distribution? We have this mean and this standard, this variance. Okay, so W is normally distributed with mean 17.6 and variance 1.332. Right, now, so this is basically probability of W being less than 18. Alright, where minus minus becomes plus, probability of W being less than 17 and minus 1. So how are we going to proceed? Standardizing, we have P of Z being less than 18 minus the mean, which is 17.6, all divided by the square root of 0.1332. Okay, plus the probability of Z, okay, being less than 17 minus minus 17.6, all divided by the square root of 0.1332, and then you minus the 1. Okay, so what that's going to be, if you work all of that in your calculator, you're going to end up with phi of work that in your calculator 1.096. okay, plus the phi of this one. Remember, this is negative here, but we already worked with the greater, the sign of being greater has been changed to sign being less, so we're going to take this as positive now. 17.6 minus 17 is 0.4, and divided by this, and you're going to end up with 1.644. Right, and so you minus the 1, and if you check it out from your table of values, you're going to get the phi of 1.096 is 0.8635 plus 0. For this one from your table, it's going to be 0.9499, and all of that subtract 1, you end up with 0.8134, and therefore your answer is 0.813, 3 significant figures. And this is the probability of a rack, okay, full of a rack full of 12 bottles being between 17 and 18 kilograms. Okay, so move on to the second part now. 2 bottles of wines are chosen. Find the probability that they differ in weight by more than 0.05 kilograms. So if 2 bottles of wines are chosen, what is the difference in their mean? So difference in their mean. Maybe I could say E of x1 minus E of x2. That's going to be 1.3 minus 1.3. and the difference in their mean is 0. Okay, what is the difference in their standard deviation? So we're going to be taking the standard deviation that was given in the question, 0.6 kilograms for the bottles. So I'm going to say 0.06 to the square minus 0.06 to the square. Now here is a very important fact that we need to remember, is that if you have the variance of x minus y, that's going to give you then the variance of x plus the variance of y. So variance of x plus variance of y. So we're going to add up, so that's going to become then 0.6 to the square plus 0.6 to the square is 0.036. Check it out. 0.06 to the square, 0.0036 plus 0.0036, and that should be then 0.0072. Now, for the difference that they differ by more than 0.05 kilograms, so we have the difference being normally distributed with mean 0 now, and standard deviation or variance 0.0072. And for that, if it differs by more than 0.5 kilogram, we have first of all P of D being greater than 0.05, and we have the probability of D being less than minus 0.05. We have two extreme values here. For this one, for the first one, what is it going to be? So just put it here. Probability of the difference between greater than 0.05 is going to be exactly the same as probability of z being greater than 0.05. okay, and yeah, so what that's going to be, well it's going to be 1 then, minus the probability of z being less than 0.05. okay, so we have 1 minus z being less than 0.05 minus the mean 0, all divided by the standard deviation 0.072. okay, this is what we have, and if you do that on your calculator, okay, you're going to end up with 1 minus phi over 0.589. yeah, what I mean by that is that this one here, if you work it out in your calculator, you're going to end up with this value. Now this one from table, you can check this out from your table, and you're going to get 1 minus the phi of 0.589 is going to be 0.7221, and therefore if you do the subtraction, you're going to end up with 0.278. Now the other thing is that we have to do the probability of d being less than minus 0.05. Now if we look at the standard distribution curve, let me just go back there. If this is minus a, we have p of z being less than minus a. okay, we're looking at p of z, okay, being greater than, because if you reflect it on the other side, being greater than a then, and the table of values, the graph is not going to give you greater than, so we're going to take 1 minus p of z being less than a. So this is basically what we're saying, that it is p of 1 minus p of z, okay, being less than 0.05. We just worked out this from our, previous on our calculator. This is it. It's going to be then 1 minus the phi of 0.589, and again we have 1 minus 0.7221, and that's going to give you 0.278. so we have one probability here. The probability that they differ by more, the two bottles will differ by more than 0.05 kilograms in weight, is then going to be 0.278 plus 0.278, and that's going to give us 0.55623 significant figures. Well, quite an interesting question. I hope you've been able to get some help from this one then. Take care.